So remembering how to calculate your change in enthalpy and entropy is pretty easy when we remember that we always do sum of our products minus sum of our reactants. So labeling this reaction here, we know that this is our reactant side, this is our product side. So going through and doing our delta H, remember our delta H is equal to the sum of our products, so in this case sum of whatever it says for our H2 and our O2, in this case it's half, minus the sum of our H2O. So plugging that in, I see that I have 1 mole of my H2. I have like an invisible little 1 here. So I'm going to multiply that mole by whatever my delta H is. In this case, I see that it's actually 0. So I have 0 plus 1/2. And it's also 0 for my O2. Remember that 0 is an element's standard state of heat of enthalpy. Then I have to subtract, though, my 1 H2O, which in this case is negative 285.8. Kind of running into my picture here, but we have that value that we plug in. So subtracting a negative in this case is basically just going to be adding all of this together. So my value is going to be positive 285.8 kilojoules per mole for my delta enthalpy. Now I'll do the exact same thing for my entropy, but I use my entropy values from my chart. So my delta S is going to be equal to, remember I have my products, so I have 1 times whatever my product is here for my H2, 130.6, plus I have half for my O2, half a mole, but my value for that is 205.1. Remember, these are my products, so now I'm going to subtract my reactants. I have 1 mole of my reactant that I'm going to multiply by my 69.9. This is that value from the chart. And the value that I get for this is going to be equal to positive 163.25 joules per Kelvin times mole. So those values were pretty easy. Remember that pure gas is equal to 0 for your change in enthalpy, but not in your change of entropy. Remember our third law. If you're confused about your third law of thermodynamics, go back into your notes and take a look at that. But moving down to calculate our delta G based on those values that we just got, remember that our equation for calculating delta G is equal to delta H minus delta S times T. So plugging in all the values that we got, we just want to make sure that all of our units are the same. So we have our 285.8 kilojoules per mole of our delta H, but I know that my delta S, the value that I originally had, was 163.25 joules per mole times Kelvin, and I want that to match my kilojoules over here. So I'm going to multiply 1 kilojoule over 1,000 joules to get a value equal to 0.163, oh, I don't have a period there, 0.16325 kilojoules per mole times Kelvin. So when I plug that in, I'm going to subtract my 0.163 times my temperature in Kelvin, so 298. And my final value that I get is 237.2 kilojoules per mole.